Hello, everybody, and welcome to Chapter 21, Cost Behavior and CVP Analysis, or Cost Volume Profit. All right, again, we're accountants, even though we're focusing on managerial accounting, and therefore, when we say cost volume profit analysis, we're literally going to analyze the cost, the volume, and our profit. I'm not joking, okay? So don't read too much into this if you're thinking there's some other hidden agenda in this. It really is going to be going over cost behavior in these concepts in this chapter. Here are your learning objectives, and pause it if you want to read those. Very important, but except for the analytical, wait, nope, that's fine. That's fine. Procedural P1, we're not going to go over that one. Okay, we may not go over some of the other stuff. We'll see. Okay, let's talk about different types of costs. When we're looking at costs, we're looking at different types of movers in the cost area. And what we're talking by that is that, I mean, there's cost behaviors here and stuff like that, but what I'm specifically referring to is the different types of costs and how they interact with how many of the products we're making and how it's going to attribute to our profit. So, with that, yes, these are all questions that we need to predict as managers, but let's go into each specific area and evaluate each one. The first one is a fixed cost. Over time, in total, fixed costs will not change. If you have a rent expense for your factory and it's $5,000 a month, it's not going to change whether you produce 1 unit or 100 million units. It's still going to be $5,000 per month in total. Now, the last bullet point is what really gets some students and gets them confused. So please don't get confused by this. What the second bullet point is saying, unit fixed costs decrease as volume increases. What that's saying is that because total cost or total fixed costs don't change no matter how much you make, saying that the more you make, if you were to break that down on a per unit basis, then it would decrease as you increase in volume. But we're not going to really focus a whole lot of fixed costs on a unit basis. We're going to simply look at it as a fixed cost that doesn't change over time. Next cost is called a variable cost, and variable cost is directly tied to the number of units that you make. So the total variable cost changes in proportion to the volume that you are building or making in a manufacturing company. So if you build 5 units, it's going to be $5. You build 25 units, it's going to be $25. It's going to be proportional, and it's going to be no matter how much more you make, it should increase that same variable cost as you increase it. Now, what it's saying on the second bullet point is that unit variable costs, or excuse me, the first bullet point. So I'm sorry, maybe go back to the fixed cost really quick. The first bullet point is what's illustrated by the graph that you're seeing on the screen right there. On the variable cost, it's the second bullet that's being displayed on the graph on this slide. Total variable costs are going to change in proportion. Hold on, I got to read that again. Total variable costs are going to increase over time as you increase in volume. But the per unit cost, if it costs $1 to produce a unit, it's still going to cost $1 per unit, whether you build 1 unit or 100,000 units. Okay, that's what that's saying, and that's what the second total variable cost change in proportion. I guess the first bullet does display the variable cost here. It's just really the wording, and see, even I get kind of fumbled in trying to explain it because of just how it works and everything. So just as long as you're looking at it in total, as fixed costs in total aren't going to change no matter how much you make, total variable costs will increase in the more that you make. That's what I'm trying to say. All right, so when we're graphing our fixed and variable costs, we're looking at it from this standpoint. We're seeing that variable costs we'll focus on the top part. The green line is your total costs. The fixed line is your red line there. It's orange, or I guess it's supposed to be red. and it looks like it's fixed at around $32,000. And then you have your variable line, which is $20 per unit, starting at 0, 0. But as you apply both of them, it's going to show you your total cost model. What they're trying to show you in that second graph is that no matter how many units you make, let me use my mouse, sorry. This one's the variable cost per unit, starts at 20, 0, 0. If you make 0 units, you're going to spend $0. You make 1 unit, it's going to be $20. You make 2 units, it's going to be $40, and so on up this list. 32,000 no matter how many units you make. And then the cost when you merge both of these together is more what you're looking at in a fixed variable combined costing model. That's what your real costs are. Now, looking at it from this standpoint, this was total cost. This is per unit costs. When we're looking at our fixed cost per unit, it's saying that it's not saying that as we make more that our cost goes down. It's just that we have more volume to spread those fixed costs over. And so thus it appears to decrease over time. But you're still spending $5,000 on your rent. It's just that whether you have 200 units to spread that over or 400 units to spread it over or whatever will make it to where that fixed cost changes with the number of units you make. Variable cost per unit, no matter how many you make, it's still going to be $20 a unit, $20 per unit, $20 per unit. That's what these graphs are trying to show you. And then this is your total cost per unit as it shows going down. Anyway, we're going to be living up in this world right here. You do need to understand and know this though, but I'm going to be focusing more or less on looking at total costs in this chapter. Mixed cost is what we're looking at here as our total cost, this green line. It doesn't start at 0, 0, and it's not flat like fixed costs. It's accumulating both a fixed component and a variable component. So we're going to start at some point on the y-axis. If I didn't say this at the beginning of the chapter or beginning of this video, if you love graphs and formulas, this chapter is for you. If you don't, you got to get through it. So sorry. If you do, we can work with you though. Okay, we'll get you there. You start off here at some y variant that's higher than 0, and then you're going to increase from there. A lot of companies are going to see this in salesmen or saleswomen who have a fixed monthly salary and then receive a commission on sales. That's where you're going to see a mixed component cost. Or maybe you have a supervisor salary that is a flat salary, but then with a certain number of units they produce, their salary goes up. So that's kind of what we're looking at with a mixed cost. Then we have a stepwise cost. Most of these are going to be your supervisors most of these are going to be your supervisors on the production line. A supervisor can only produce and observe and supervise so many production lines and so many units. At some point, there's just with the finite amount of time that a supervisor has, at some point, that supervisor is unable to supervise more units being produced. At which point, then you create a second assembly line, or at least another assembly line, and start producing it with another supervisor there. And so thus, at 1,800 units created, you can stay here at 10,000. But the minute you hit 1,801, you're going to need a new supervisor. And so you're bumping that up by the amount of the supervisor's salary. And so on and so on. That's kind of the idea behind that one. Here's some cost examples. Fixed costs. I started off with rent, okay, property taxes, insurance. Stuff that isn't going to change over time based on the number of units. Now, depreciation is listed there, and they note the exception is unless you're using units of production, at which point then it would be a variable cost. But for the most part, we're going to be doing depreciation as a straight line depreciation method, so you can assume a fixed cost there. Unless it says otherwise. Variable costs, typically your direct materials, direct labor, packaging, shipping, etc. Mixed costs, you have your electricity, water, maintenance, sales rep, like I said before, salary plus commission. Electricity and water. Now, a lot of people aren't aware of this or whatever, but it's important for a utility to have the infrastructure ready for the highest demand. So let's think of Phoenix, since this is where I would assume most of us live, or at least in the Arizona, in the valley, in the heat somewhere. Um, Naturally, we would assume that most people are going to use their electricity the most on their air conditioning in the summertime. So summertime is when peak demand occurs. And that's why a lot of these places will increase their costs in the summer. The SRP, APS, Tucson Electric, etc. Um, Brian, why do you know so much about electricity and water and stuff? Oh, well, let me answer that for you. I actually worked for the Corporation Commission for a few years where I was a public utilities analyst. So I know a little bit more than the layperson about this stuff. Nevertheless, they need to have enough infrastructure to cover the peak moments. Even though in the wintertime, our rates all go down, that's because they have to utilize less of their infrastructure. And so that's why the cost of it goes ebbs and flows. You go up to somewhere else, like say, and I'm just going to spitball here, and I could be wrong because I've never lived in these states to know for sure. Um, but I have some relatives that used to live in Idaho and Utah and I don't think Wyoming or Colorado, but I also used to live up in Seattle. They don't have air conditioning, and in the wintertime, a lot of them do wood burning. So their electric rates tend to be focused more on just your average lighting and everything else. So their demand is a relatively flat stream of use. So the predictability or I should say, the variance is not as bad, and so their predictability is high, and therefore they don't have to do the up and down. But long story too long, sorry. The point of this is that you pay in your electric and water bills a fixed cost relative to maintaining the infrastructure, and then you get charged a per unit basis. If it's water, it's per thousand gallons. If it's electricity, it's per kilowatt hour. And that's how that works. So that's why it's a mixed cost. Now I'm making this video. This video is going to be over time. Right now, I do have a cost volume profit analysis that we do, and I will reiterate this in that assignment. But I want to make sure if you're watching this and you're not in my class, then disregard this. But we have to account for in this example of utilities. But for simplicity and because we don't have the specificalities that this person's given us, we're going to put that as a fixed cost. Okay, so list it as a mixed cost, but analyze it like a fixed cost in our assignment. And you'll know more about that when you get to it, but just be aware of that. I want to bring that up to you now, but it is a mixed cost. And then stepwise costs, like I said, add or drop a shift, workers, production line, warehouse, sales regions. Basically, these are your managers, people like that you're going to be using. So. Okay, so I've left this slide in here to remind me to tell you that we're not doing it. All right, scatter diagram, high-low method, and regression. I'm not going through those methods to estimate costs because we're just not going to. We want to deal a little bit more with the knowledgeable things, so we're skipping over that one. So there's about 6 slides in there. If you're following along with your slides and creating notes, go ahead and skip to, I believe we're on now slide 18 of that slide deck, and we'll go from there. Compute the contribution margin and describe what it reveals about a company structure. Now we're getting into the formulas here. You're going to be living in these formulas, so please make sure you pause the video on each of these slides with one of these, or print off the slide or whatever, because having these formulas, or write them down, formulas are going to be handy, very handy. You're going to be doing this a lot. So I just dropped my lid. Have you ever noticed when you're drinking a water bottle and you drop the lid? Oh, there it went. It never lands like up like this. It always lands face down. So you got to be like, oh, I got to wash it out. Well, the one time it actually landed up. That was good. The way we calculate our contribution margin per unit is we take our sales price per unit minus our variable cost per unit. So if we have a $100 selling price, as the example here shows, and we subtract out our variable cost of $70, our contribution margin per unit is $30. In other words, each unit we sell is going to have $30 of it being able to contribute to our total fixed costs. Remember, we have our fixed costs we have to cover. And so if we're only selling a few units, it's not covering our fixed costs. We got to sell more in order so as to cover the fixed costs. Now, how do we calculate the contribution margin per ratio? We simply calculate the contribution margin per unit, and then divide it by our selling price. And that is our contribution margin ratio. You're going to need both of these to help us calculate the break-even point of a company in their sales. And without further ado, we're going to do that right now in a single product company. Break-even point is where our income is zero. We sell just enough to where we don't make money, but we don't lose money. We have just enough to sell to make sure that our fixed costs are covered and our variable costs are covered, and that's it. We have no profit at all. Now, let me ask you this. Can a company survive this way? Absolutely. Company can survive, but I can guarantee the investors aren't going to be too happy because they're never going to see a dime of it. But that's why profits are there as well. But we do have a lot of companies that we call nonprofit organizations, and that's exactly what they mean. It means that they're only selling their product for what it costs to cover the creation of their product, and any additional amount of money they may have is because they're planning on creating more of their company and branching out to other things that they can do. So there are methods to nonprofits and why they do that, but the break-even point is for mainly, well, I mean, it's for them too, because it's basically their cap on what they should make. But so here's the formula method to calculate break-even points in units. We are going to take our total fixed costs, and divide it by our contribution margin per unit. From our example before, we calculated that as contribution margin per unit was $30. So we can take our fixed costs and divide it by the number of units that we have to, or the contribution margin per unit, and that will equal the number of units we have to sell in order to break even. So using the formula method that we did before, with a $100 selling price and $70 of variable costs, 800 units is what has to be sold in order to make our break-even point. What's our break-even point in the actual dollars? Well, you can calculate this in one of two ways. First, you can take your fixed costs and divide it by the contribution margin ratio. $24,000 divided by 30%, or 0.3. That's going to get you $80,000. That's what the amount of money you need to make to cover your fixed costs and your variable costs without making a dollar. Now, you can do that, but if you happen to know the number of units you have to make, in other words, your break-even point in units, and you know the selling price of $100, you just take 800 units and multiply by $100, and that'll give you $80,000 as well. Both ways are just fine. Here's your contribution margin income statement. You take your sales minus variable costs, get your contribution margin, subtract out your fixed costs, and get your net income. If you set your income to zero, and you know your sales and variable costs, you can calculate everything else. As long as I give you three functions or three parts of this information, you should be able to calculate the last one. In fact, I could probably just give you two of these parts and you should be able to come, because you already know income is supposed to be zero for your break-even method. So put a zero there, and if I give you variable costs of $56,000, no, I think I still need to give you another one. I need to give you at least sales and, yeah, or at least the selling price. You could work through it at that point. Anyway, that's a method, but we're going to focus probably on the formula method. Here is your cost volume profit, or CVP chart, okay? This is the loss area. This is a no bueno zone. This is where we don't want to live, this pink zone, okay? Here's our red that represents total costs, and here's our green that represents total sales. At the point of intersection is our break-even point. 800 units or $80,000. The minute we sell one additional unit after that, we are now making a profit. And since we've covered our fixed costs, what we're going to see profit is for after our break-even point is every amount of the contribution margin. So if we sell one unit, we're going to make $30. If we sell two units, we're going to make $60, and so on and so on. Now, what happens if we have to have a change in estimate? Well, we just calculate it out, okay? If we have a revised break-even point in units, we have to recalculate, we just move on to it. And this is an exhibit you can look at and kind of just gloss over and stuff like that if you want to. I'm not going to be focusing a whole lot about changes in estimates, though you'll probably see some of this in your homework. All right, so how do we apply this? What do we got to do in order to use this information to our benefit? Well, we want to know what our margin of safety is, okay? We want to do better than our break-even point. I'm sorry, I got distracted with someone saying goodbye. Anyway, our margin of safety is equal to our expected sales, what we expect to sell, and subtract out our break-even sales and divide it by our expected sales, and that's going to give us our margin of safety as a measure of percentage. So, and that's something that where the management will come up with this and decide where it's at and what they feel is where it needs to be set at. So if we expect to sell stuff and our margin of safety is below 20%, we think 20% is where it needs to be, then we have to refigure our sales price or find a way to cut costs. Here again, expected sales and costs using the income statement approach. Basically, they're saying they need $21,000 of income to feel safe, to feel like, hey, if we achieve this, how much are we going to make? That's where we're at, kind of a thing. But what we're going to focus primarily on is computing target sales. We're not going to just say, hey, how much money are we going to make if we sell this number of units? We want to know how many units we need to sell in order to make a specific target income. So let's look at it from the perspective of a target income. And we're going to look at this from the standpoint of target income in dollars and target income in units. So in this case, we're going to take, to find out our dollar sales at target income, we take our fixed costs and we add target income to it and then divide it by the contribution margin ratio. If you think about this algebraically, just take the fixed costs and assume your target income is part of those fixed costs. Hey, you need to make enough sales to cover this amount of money. And so in order to do that, where do we get to that where those lines then cross? And as you do that, that's where you're going to get your dollar sales at target income. Then we need to sell $120,000 so that we can make a $12,000 target income. That's the point of this. Interestingly enough, we should be able to take 12,000. Well, I don't know where that number came from. We should take $12,000, and our contribution margin per unit was $30. 400 additional units. So the question is on the next slide. I hope it's true, because if not, I'm going to look funny. On the next slide, we should see that we need to create 840 units. Excuse me, I'm sorry. 812. We need to make 1,200 units in order to achieve this dollar income. Okay, so let's see if that is the case, if we need to do that. Oh, good. I'm not. All right. Algebra works, guys. That's what I just used. 1,200 units is what we need to make in order to achieve our target income. Okay. And again, if you know the number of units, it's 1,200 units. Multiply that by the selling price. That should equal your 1,200 anyway, as we did here back, or $120,000. So we're good to go. All right. All right. Contribution margin income statement, work backwards. If you want to make $12,000 and you know your fixed costs, you know how much contribution margin you need. So then you got to calculate your variable and your fixed costs, or excuse me, your variable costs and sales. Once you do that, you divide that by your contribution margin per unit, or your contribution margin, ratio for your sales, and that should be able to give you that information. What that does is tell you what is your sales and variable cost per unit? Well, we really don't know. You probably can do that by taking the number of sales and dividing it by the number of units you sold to get there, and that should give you that information. But again, I'm not going to make you do a whole lot on this contribution margin income statement stuff. You need to not do it, but you don't need to worry about fixing it up and making it and stuff. Maybe for some homework stuff, but not in the exams. Revised break-even point in dollars. Basically, you're just calculating your revised fixed costs and dividing it by your revised fixed contribution margin ratio. It's really simple. Shouldn't be that big of a deal. Same thing with your revised margin of safety. You take your expected sales, subtract out your new revised break-even in sales, and divide it by your expected sales. Just, basically doing the same thing. You're just reworking it because of something that you had to do. Multi-unit. Let's not do multi-unit. Let me give you your word right now as we finish this chapter up. It's 21. The word is cream. C-R-E-A-M. Like I love to put whipped cream on my ice cream. C-R-E-A-M. Charlie, Romeo, Echo, Alpha, Mama. I think Mama, right? Mama's the M for military. I'm starting to go fading with the phonetic alphabet in the military. I haven't done it in so long. Don't worry about this compute the break-even point for a multi-product company. I'm not going to throw that at you. I just want you guys um, to know that. Let us just look at the degree of operating leverage. Again, I just want to bring this to your attention. I don't expect you to know this or calculate or anything, but you take your contribution margin and divide it by your income. This is going to tell you what change in the level of sales will be on income. Tells you kind of how much it's going to be. So it's not, it's definitely something you want to look at and everything, but it's something that you want to make sure that you're aware of. So basically saying that if your sales increases or decreases by 10%, you're going to see a 30% change, or roughly thereabout. I wonder if this math is going to calculate out. I'm going to do that again. I really like to see because sometimes these slides kind of screw up. And let's multiply by 0.3. So 3,600. Let's add 12,000. So that's what it's doing there. You saw that I multiplied by my current amount and got to 15.6. If our sales increase by 10%, then we should see an increase in the sales in that regard. And I'm suspecting that if we subtract it out, we're going to get that 8,400. Yeah. So if sales decreases, our income is going to go down. That's our leverage. That's what we're able to use this for. Something to just think about. It's like I said, nothing too big. Just want to bring it to your attention. I will go over this just briefly using Excel for cost estimation. You can use your intercept, slope, and things like that. This is kind of what I passed on before, but I want to point out that Excel does have those things for you. Nope, not going under absorption and variable costing. So with that, I think we're done. Yeah, we're done. I'm not going to go over this other stuff. Some of this stuff in the appendices, it's not that I don't want to or think it's good that you know that. It's that it's kind of advanced, and you're just learning this for the first time. I don't want this thrown at you. What's going to happen is when you get into your cost accounting classes at the university level, they're going to dive into those things a whole lot more, okay? They expect you to come with the basic knowledge that I'm teaching you, and then from there, they're going to expand on it. They'll give you some refreshers, I hope. But otherwise, you'll go through all of this stuff in a little more depth, and they're going to go through the absorption costing. They're going to go through CVP analysis with other factors and multi-product companies and things like that. So don't worry, you will see it. It's just I don't want to throw it all at you right now. So you're definitely getting your money's worth here. You're just going to get it a little more next time in those advanced classes at the university level. All right, that's it for chapter 21. If you have any questions, please let me know. Guys, don't put this off. If you're falling behind right now, if you're struggling, you've got to reach out to me. I might catch on and look at your homeworks and stuff and see that you're not staying up to snuff. I might reach out to you and say, hey, what can I do? But really, ultimately, whether you succeed in this course is up to you. So please make sure you reach out to me so that I can help you succeed in this class. Your success is my success, and I want you to be successful, okay? All right, take care, guys. We'll see you in the next movie, video, whatever. Hit subscribe. No, I'm just kidding. All right, take care, everyone.